Hello and welcome to physics video Waves.5a, shockwaves and sonic booms. In this video we will be discussing how shockwaves are formed, what they actually are, and how they are related to sonic booms. If a source is moving faster than a wave speed in a medium, the waves cannot keep up and a shock wave is formed. If we take a look at these four pictures here, you will see the differences as the speed of the object or the source is getting faster and faster. Picture A, we have a stationary source, and of course it looks just like it typically does. It's symmetrical in all directions. Then as the source starts to move to the right, the wave front begins to pile up here and spread out behind it, as we talked about in the Doppler effect. When the speed of the object reaches the speed of sound, then the wavefronts aren't just getting closer and closer, they actually pile up on top of each other. And at that point, the object creates a sonic boom, a loud boom sound, due to the large number of sound waves produced at once. As the object starts to travel faster than the speed of sound, the newly emitted waves end up in front of the waves that were produced previously, making this shock wave and the shock cone shown here in picture D. The angle of the shock wave is determined by how fast the object is moving relative to the speed of sound. This is what we talk about in terms of being at Mach 1 or Mach 2 or Mach 0.5 or things like that. And we'll come back to that a little bit later. Anything in the path of the shock cone here, anything within this space, is going to hear a sonic boom. Let's take a look at what these are in motion. So let's take a look at an animation. On the left, you see the animation of the stationary object, so the stationary source, again circular in all directions. Next, we move to the source being less than the speed of the wave, but the wavefronts are starting to get smaller on the right. When it equals, you can see right from the get-go, you have a pile up and you'll be listening to a sonic boom the whole time. And then as it goes faster, that sonic boom turns into a shock wave. And within that cone is where you can hear the sonic boom. It's not just fast objects, and you don't have to break the sound barrier in order to create these shock waves. Let's take a look. Birds can create shock waves. So over here, you can see that this swan is creating shock waves in the water. You can see it going out in a cone-shaped fashion here. We also have a couple of ducks in line. This is a pretty cool picture because they have envelopes that are within each other, and they must be moving at the same speed because those envelopes are parallel to each other. And then, of course, we can have planes or boats or super fast cars creating shock waves. This picture up here is of a boat, and you can see the shock wave is even larger than with the birds. This bottom picture is pretty cool. This is actually a rocket car, and it is breaking the sound barrier. And you can see in the picture right here in the center, you can see that as it does this, the shock waves are not just going back behind it, but they're also in all dimensions. So you can see the air being distorted there, and that distortion is due to the shock wave that it's producing and the sonic booms that it's producing. In class tomorrow, we will discuss how to calculate the size and location of the shock wave and the sonic boom, as well as discuss how these speeds relate to Mach numbers. So this was just a quick intro to what's going on. So bye for now.